Hello, everybody. I'm Garan.
I'm Paul.
And in the next 30 minutes, we'll be covering new experiences and new ways in which we've made it easier to build for the wrist, for the road, and the remote control. So let's get started. Let's take a look at what's new in Compose. So Compose is now well established as our single approach to building Android apps across all form factors, from TVs through adaptive screens to Wear OS. And at I/O this year, we announced that we're going Compose first. I'm sure probably a lot of you heard that. Compose makes it really easy to reuse knowledge, to reuse code across your app, making both development and maintenance easier. So our colleagues Diana and Emily showed how to design apps for UI capabilities instead of specific form factors. And you should check out their session called Adaptive Development for the Expanding Android Ecosystem that contains some great examples of following your app, of allowing your app to react to things like if there's a pointer or a keyboard available, posture changes, or hardware capabilities like microphone or camera.
Yeah, in Compose, most of our components work great out of the box. They work great across all the different form factors, and we're continuously improving Jetpack to make it easier to build adaptive apps. So Compose is now the way to build for Android across all the different form factors, and you can use the core and material Compose components to leverage adaptive app principles. So you've probably heard us at Google use the word adaptive a lot. And the thing is, it's not about optimizing for foldables or for laptops or for any specific form factor at all. It's more than that. Adaptive is about thinking beyond form factors. It's about building robust, reliable app experiences and meeting your users' expectations across any surface. So like when my brother buys a tablet, he doesn't want to worry about why an app doesn't work with, like, it doesn't show full screen or it doesn't work with a stylus. He's just looking for like what kind of cool things he can do with it, right? So the reality actually is that users are not on a single device. They might start watching something on their tablet. They might continue watching it on a foldable in the train, for instance, and then sit down in front of the TV and watch it from their couch. And they expect that that experience flows seamlessly across every device and every surface. Users don't think about form factors. They think just very simply whether the app works or whether it doesn't work. So we've been working to improve this framework and our libraries to help your apps run across the ecosystem. And we hope that you can also adopt this adaptive mentality. So as an example, let's take a look at two component libraries, Grid and FlexBox. There's the two components that help you build adaptive layouts that work across differently sized devices. Grid is a versatile layout that allows you to build highly configurable two-dimensional layouts. It's great for defining structural elements on the screen. But note that it's not to be confused with the components like lazy vertical grid and lazy horizontal grid. Those are, as the name suggests, lazy components and are intended for displaying large data sets. So that's a completely different use case, to be clear. Configuring a basic grid layout is very straightforward. Here in this example, I can set the number of columns and rows with an exact dimension, and all I have to do is pop in all the different cards. But there are a wealth of options that you can use to change the behavior in the grid, tracks, and cells. For example, like you can see in this example, adjusting the order in which the cells are populated, for that I can use the grid flow property. And grids are also flexible. In this example, the space taken by the third and fourth cells is flexibly apportioned once the other fixed and percentage-based cells have been calculated. And you can see how I've done that here with the .fr property. And grids can also be sized intrinsically. The behavior of each cell itself can be adjusted in numerous ways to create bespoke layouts, including alignment and spanning. All right, now let's take a look at FlexBox. If you're also a web developer, or if you're familiar with CSS, you'll be right at home with this. It even shares the same name as the CSS counterpart. FlexBox is great for a small number of items within a bigger layout. For the overall layout, you should be trying to use that grid layout that I was showing you earlier. And for a large number of items, for in a larger data set, try using the lazy loading grids that we're very familiar with. FlexBox works in one direction, either laying out in a row or a column, and it offers lots of options for controlling the wrapping, positioning, and sizing of items. So here, for instance, there are 5 items. And they're configured as a row with wrapping enabled. And also with 3 of them expanding to fill the remaining space by using the grow option. To apply a configuration to a FlexBox, you just pass in the configuration lambda, like here. Direction, wrapping, alignment, these are just some of the many options for how you can configure the overall container. And you can use the flex modifier on individual items to control aspects, such as how they should grow or shrink, depending on the available space. Here, the text component on the left has a shrinking enabled, but the one on the right has shrinking disabled. And if you want to take more control over how you can customize your UI per form factor, you might want to take a look at the experimental MediaQuery API for Compose. This provides a declarative way to query the environment with specific signals like window size or pointer precision. It reacts to different device capabilities that may change in runtime and allow your app to adapt its UI in runtime. You might use MediaQuery to offer different layouts dependent on the viewing distance to the screen. So instead of checking whether a device is an Android TV specifically, you might instead consider adjusting font sizes in your UI when the user is interacting with the device from afar. We can use the MediaQuery function, which evaluates the query lambda and wraps the result. And here we use the viewing distance property to determine the right breakpoints. Or you might want to conditionally enable parts of your application dependent on device capabilities, like whether it has a camera or a microphone. And like before, we use the MediaQuery function to query, but this time, whether it has microphone or has camera. And we use that to determine whether the associated UI should be shown. So this is really easy.
So across Android, we've made the playback experiences work easily using Media3 and Compose with the Media3 UI Compose library. This library adds state hoisting between video playback and your Compose UI. And as you can see here, we've introduced a player composable, which you combine with your existing Exoplayer instance. And you should take a look at our latest samples that show how elegant a Compose implementation can be across a range of scenarios. It's libraries like Media3 UI Compose and Media UI Compose Material 3 that make building apps using Compose the best way to build for Android.
Ultimately, our goal is to bring more components into shared component libraries, so you don't need to rely on specific variants like Compose for TV. For example, we recently merged scroll containers into Compose Core, so you don't need to implement a specialized one for TV, and your content and lists and grids can be browsed natively using a single dependency. In addition to the form factor agnostic libraries, note that specialized libraries in your app can let it stand out by form factor. TV, for example, includes carousels and cards. XR includes subspace composables like spatial panels and orbiters that you just heard from Derek. And the library for Where includes specialized buttons and scrollable containers.
Talking of lists, Paul, has anyone got a Pixel Watch? Anyone wearing a Pixel Watch today? Oh, quite a few. Great. OK, so you'll know that the round watch shape requires a very particular visual transformation. Those of you who are familiar with using previous versions of Where Compose will know that it can take quite a lot of work to get this just right. Last year, we introduced transforming lazy column as our recommended approach for building lists in Wear OS, and we've now enhanced it to be even easier and also added some new features. So transforming lazy column can now automatically take care of calculating the correct padding. If you pass content padding directly from the screen scaffold to the transforming lazy column, and then use the new minimum vertical content padding to ensure the correct padding is used at the top and the bottom of the list. And it accounts for different screen sizes and different system fonts. There's defaults for all the standard components, such as buttons and cards. And in this example, you can see a list header here. So the developer really doesn't have to do anything at all to ensure that the extremes of the scroll, top and bottom of the list, are perfectly positioned. We also added the new reverse layout parameter that reverses the layout, as the name suggests, starting with the scroll position at the bottom instead of at the top of the list. And this is really great for messaging apps. In Where Compose 1.6, we also introduced a new snapping behavior to fling actions on your list. So if you want your users to be able to really fling the list, but when it actually stops, have that item perfectly centered in the screen, then this is what you can use. And we strongly recommend that you combine it with a rotary snap, as you can see here in this example. So if they're using the bezel or the scroll wheel as well, you get the same behavior. Apart from lists, we've also brought Where Compose 1.6 in line with other surfaces by introducing support for Nav3. To integrate with Wear OS's specific action of having swipe to dismiss, we've added a scene strategy just for Wear OS. You can see it here, swipe dismissible scene strategy. There's a full deep dive video into Nav3 from this year's main I/O, so do check that out. It's on the Android developers YouTube channel. And then finally, we've introduced ambient support within Where Compose directly. So if you've tried doing this before, you will have implemented an ambient lifecycle observer, which is quite complicated. And now you've got the option to do this directly with Compose, and you can define behaviors for both ambient and interactive visualization there.
Oh, very cool. On Android, on Compose for XR, a new composable will help your app enter full space, which lets your app make use of the full spatial capabilities of the device. You can query for XR capability support using the local spatial capabilities and show a space toggle button. Those are tongue twisters. And on display glasses, Jetpack Compose Glimmer provides a distinct visual language for experiences that feel natural on these devices, offering simplified styling, optimized color defaults, and differentiated focus indicators. Jetpack XR libraries are preparing for their first beta release, bringing more API stability, but in short, they are ready for production-level apps. So hopefully you were able to see Derek's session earlier today. It's titled Bringing 3D Experiences Using Jetpack XR. He showed how to bring adaptive app into the third dimension. And in case you missed it, don't worry, it has been recorded, so you can catch up on that later.
Great, and XR is not the only way in which users are interacting with devices in new ways. Has anyone tried using their Pixel Watch? Those of you who raised your hand earlier, when you've got gloves on or you're, I don't know, on the move, it's not always easy. And that's why we've introduced one-handed gestures on the Pixel Watch, which came out with Wear 6.1. Now with Wear 7, we are going to expand the reach of gestures. We've launched a new one-handed gestures framework that allows OEMs to map individual gestures to actions and dismissals, and also added an API to bring gesture control to the developer community. Starting in Compose 1.7, you can seamlessly integrate gesture control into your Wear Compose apps. The new API enables subscribing to gesture events, and also it provides a consistent built-in hint behavior to intuitively guide users. An early adopter of the Gestures API is Spotify, so you can see here on the screen. And they've integrated the gesture control into their media app. Spotify users are going to be able to pause and resume with a simple gesture within the Spotify app itself. So let's take a quick look at how you would add gesture control to an existing button in Wear Compose. So the key part is this modifier here, one-handed gesture, which declares that this button can be controlled by a gesture. And you'll notice that we're assigning it to the primary action, which on the Pixel Watch is a double pinch like this. We've also added that we want it to work in ambient mode too. And that really is basically it for the simple case. However, there's one critical piece to highlight here, which is the on-show indicator. This is a vital step to help the developers let the users know that this button can be controlled by gesture, because looking at the watch, how would you know? The system will call the on-show indicator, Lambda, when the component is visible and has priority for the gesture. And we set gesture indicator visible to true here, and we'll use that to show gesture hints. And to help with that, we've added this gesture indicator component, which is a wrapper for the button content. So you should be able to see here, you get the animation there. So what happens there is the gesture indicator visible when it's set to true, it replaces the wrap content with a hint animation, and then sets it to false once the animation is complete. It's a system-provided animation, and it will vary from OEM to OEM depending on what the physical action is required for that particular gesture. As I said, on the Pixel Watch, it's a double pinch. So in this way, the user can be guided on when gestures can be used, but also on how to perform them on the specific device that they have. We've added some additional hints and behaviors for other components, notably for scrolling and horizontal and vertical paging. So let's take a quick look at how these work. For a scrolling list, we've got the scroll gesture indicator, seen here in code, and you can also, yep, there it is, right on cue. And you should use that when setting up your screen scaffold around your transforming lazy column. It follows the same pattern of requiring a Boolean to determine when to show, and a lambda for what action to take once shown. And on the list itself, instead of using the click handler as we did on the button, we're now using the scroll down, as you can see here, to manipulate the list state. And it's interesting also to note that the gesture has a priority, which in this case is scrollable. And just to show you why that's important, at the end of the list, we've got an edge button, which has got a clickable priority. And clickable items take priority over scrollable items for gesture control. So you can see here, so it's the edge button that is showing the gesture because the edge button has got the priority there, not the scrolling of the list. Give it a go today. We'd love to hear what kind of gesture control you can add for your users, and give us feedback as we continue to develop this API.
Android tvOS is also introducing new input modalities. The Humble Television is just turned 100 last year, and boy, have they changed a lot over the years. You can't even recognize those first ones. And the first TV remote control was over 75 years ago, believe it or not. That's really old. These changed a lot, too. And this evolution hasn't stopped. As form factors blend, we're finding that users are interacting with them in new ways. Pointer remotes are coming to TV, which means that users may begin to expect to click, hover, and scroll using peripherals. Pointer remotes bring fluid, mouse-like navigation to TVs, enabling you as a developer to create modernized interfaces that are rapid to navigate through interactive hover states and scrollable containers. It unlocks new potential possibilities for content discovery, casual gaming, and yes, of course, AI. So to prepare your app for this paradigm shift, you can validate that your TV app works well for touch. Because if your app supports touch, that means that it supports pointer remotes. It's by far the easiest to build an adaptive app using Compose, because that means it works out of the box. You might consider bringing a touch-optimized tablet app to TV, or validating that your existing TV app supports pointer input by using the TV emulator, or by attaching a mouse or trackpad to an Android tvOS device. But note, if you use a mouse, you can't trigger fling events, not even with a scroll wheel. You can with touchpad or trackpads, which is why we recommend using a Bluetooth touchpad to test all the different kinds of gestures. Once you've ensured that your app works well, including both horizontal and vertical scroll, you can add a declaration that your app is optimized for touch and pointer input by declaring supports touch in this metadata tag. And here's, by the way, a neat trick. You can use this new experimental MediaQuery API I was showing earlier to determine whether a mouse or a wand is connected. Again, we use the MediaQuery Lambda function, which evaluates the query lambda and wraps the result. This lets us obtain the pointer precision and allow us to compose our UI with navigation buttons to the previous or next page. And that would look like this. And the delightful thing about this, by the way, is that as the user switches between pointer input or the keys of the directional keys of the remote control, the app recomposes instantaneously. And this is just one of the parameters of MediaQuery.
But Paul, why is it called MediaQuery?
Well, Garan, because naming is hard. Web developers may be familiar with CSS media queries, where CSS style properties can be defined for print media, desktop, or mobile displays, window width, breakpoints, and so on. But I will say, Garan, I'm glad that you asked, because speaking of audio and visual content, if your media content is available on multiple surfaces, perhaps you've heard of the Engage SDK. Engage allows you to surface content outside of your app, which allows you to drive discovery, engagement, and re-engagement. This is a great way for enrolled apps to surface content in 3 distinct ways. First, by displaying videos a user is not finished yet for resumption. Second, by matching user eligibility so that users can enjoy exploring content without needing to manually update all of their subscription information in the Google TV app. And then third, by personalizing recommendations based on content that they have been engaging with. So in short, this means that you can bring timely, relevant content from your users onto the Google TV home screen. And we're now expanding Engage to include short-form content. Check out short videos in the new personalized row on the Google TV home screen, starting with YouTube Shorts, and more partner content coming soon. And here's the kicker. Once your service is on board with Engage, you can then reuse that integration on other form factors, like mobile, to surface your content on the Google Play app and on the Google TV mobile app.
So we talked a bunch about different form factors here. And if you want to use one form factor to drive installs onto another, you can use the new in-app install prompt to prompt users on phones or tablets or foldables to install on a new form factor maybe that you've just recently launched, like TV or Wear OS or Android Automotive OS. And as a developer, you can choose the right moment within your app to display this prompt. For example, here, you can see this offers the user a non-intrusive opportunity to install on the additional form factor without leaving your app. And if they choose to accept that prompt, they'll be taken to the familiar installation page on Play to complete the installation. And the app will then just be installed in the background. Let's get back. The app will just be installed on the additional form factor in the background, and there's nothing more to do. And the flow is then completed without the user needing to access the other device at all. And the user can continue immediately on with their journey. So it's a pretty nice flow. This capability can be added with just a few lines of code. As you can see here, there's just 2 steps, really. You prepare, and then you just launch the flow. And that's it.
And for video streaming services, remember that if you'd like to distribute your video streaming app to Android Automotive OS, you can very easily add support by including a metadata flag. We even take care of compatibility mode to adjust the DPI and overlay a back button so your app is fully compatible for cars. All you need to do is declare in your manifest that your app is built for cars and whether or not you want the Android Automotive OS compatibility mode. And I have 4 exciting announcements for apps in cars. First, in addition to Android Automotive OS, we're now also bringing video apps to Android Auto. Users will be able to sit back, relax, and watch videos while parked. Apps like YouTube will be able to deliver smooth, high-quality video playback up to 4K 60 FPS. This capability will be enabled soon on phones running Android 17 and higher. As a developer, if your video app is already adaptive, making it available for parked use cases in cars requires minimal effort. To nominate your large-screen optimized video app or game to distribute to both cars with Google built-in and Android Auto through projection, please visit this sign-up link using this QR code. Second, I'm happy to share that parked-to-driving experiences are coming soon to cars with Google built-in, running Android 14 and later. You'll be able to combine the best of both worlds by offering rich experiences while parked and then transitioning to seamless drive-safe UI using the car app library. This is great for apps with content like video podcasts, and honestly, it's a terrific example of unleashing differentiated experiences in cars. So you can anticipate that the app will then switch between 2 activities, one for the car app library and another one as a conventional Android app. If you've built a car app library app already, you can then prepare by developing the parked app experience according to the adaptive app principles. And in reverse, if you have a great tablet app already, you can add the car app library entry point into your application for the drive experience. Note that you'll have to nominate yourself for publishing your app and be part of our early access program. And we're starting with media and comms app categories. In case you're not familiar with the car app library, Cal allows developers to build using prefab templates that are built with driver safety in mind, which brings me to the 3rd announcement. We just updated the templates with a modern Material 3 look, which means all you need to do is plug in your business logic because we handle the UI for you through the templates. We've added more flexibility so you can customize the layout and use a wider gamut of components to express your content, like the new templated media playback screen. And these improvements include expanded headers that bring more life into detail pages, spotlight sections that can highlight specific content, and grid item variations like progress bars to support different content types and states. We're introducing new components and template capabilities to help developers build even more engaging experiences. For media apps, we're introducing an adaptive mini player so that users can browse while still managing playback. And finally, we're adding more component types, including chips and condensed items, to increase ways that content can be displayed and interacted with. And while you can develop and test at your leisure, here too, you'll need to nominate yourself to be able to publish into production. All right, and finally, I'm excited to share some more great news. Your mobile widgets can now display in Android Auto. So the investments you've already made on mobile for the mobile widgets will soon be available to your users in their cars. So when they connect their phones to a rental car, for example, their familiar setup is waiting. Take, for example, this contact widget. It's just a swipe away. As you can see, your pinned contacts are right there on the dashboard, and the UI adapts flawlessly to the car screen. One of the incredible things about Android Auto is that your customizations travel with you. We're thrilled to unlock these new glanceable user journeys on Android Auto later this year and for vehicles with Google built-in coming soon. As widgets expand to new form factors, there may be minor differences in how users interact with them. One example is scrolling. This isn't supported in Android Auto. You can account for this by making sure that your content is placed on the first item, because the platform will display the first item in your scrollable lazy column by default. So make sure you carefully choose your first item, as this presents an excellent opportunity to show your most valuable, dynamic, and personalized use case. Learn more about the widgets experience in cars by checking out our developer guidelines.
So we're making your widgets available everywhere that your users are. And on Wear OS, this means evolving tiles to Wear widgets. This is going to ease the development experience and make it possible to build designs that feel cohesive across every device. We're introducing two initial card layouts, small and large, that perfectly align with the 2x1 and 2x2 formats on mobile. But actually, the most important and exciting part of Wear widgets is under the hood. We heard from developers that they wanted an API that was more aligned with Compose and one that was more expressive. And for that reason, Wear widgets are not based on proto-layouts like tiles were, but on Remote Compose, which is a new UI framework for remote surfaces. So we've got a quick example here, and you can see how familiar the approach is for developers who are already using Compose. Remote Compose uses many of the familiar declarative approaches from regular Compose, and it really should come naturally to Compose developers. At I/O this year, we gave a full talk on widgets, which deep dives into building Wear widgets, as well as exciting updates on widgets on mobile too. So be sure to check it out on the Android Developers YouTube channel.
Very cool to see the evolution of widgets. On cars, this creates an opportunity to unlock new user journeys on the over 250 million vehicles that are Android Auto compatible. And on Wear, combining the already very popular interactions with the unified API just makes it so much more delightful for developers.
Let's change tack completely now and talk about another exciting area that's really opening up this year, and that's agentic experiences. We're working on several options for developers to provide agentic experiences on the watch, from app functions to task automation tools. And these will enable users to complete complex watch tasks using their voices, often replacing the need completely for step-by-step manual navigation with the UI. So whilst these aren't quite ready yet, let's take a quick look. First up, if you don't have an app on your Wear OS device, you'll be able to provide an agentic experience for your users, even so. With no development effort at all, selected apps will be able to provide mobile agentic experiences that are remotely invoked on Wear OS. Let's take a look at how a user would place an order with DoorDash or Wolt for us Europeans. So you can see it here in the animation. Did it run all the way through? It probably did. Let's just have a quick look. Yeah, so you can place an order here, and then it will invoke it on mobile. Yeah. OK. But if you do have a Wear OS app, then App Functions, the API, it'll allow you to integrate your app directly with agents like Gemini. So you can invoke in-app behaviors and leverage on-device resources. For example, if you wanted to start a run with Samsung Health, users will then be able to say to Gemini, start tracking my run. Hopefully you saw Ben's excellent deep dive earlier today into app functions. Here are some of the key details that he covered. First of all, app functions allow application capabilities to be exposed to the Android platform. And this means that agents can intelligently select from a pool of app functions and how to execute a task. They can even be chained together. This enables users to accomplish complex multi-step goals using natural language. And what's more, the API surface on Wear OS is identical to on mobile. So your Wear OS app can share the same app functions module that you use on all your other devices. If you're interested in adding app functions to your Wear OS app, we're currently running an early access program for selected experiences. And if this sounds like a great opportunity for you, please fill out our early access interest form.
Very cool. Very cool. On that note, we have a few new emulators and tools to share. With the upcoming 64-bit requirement on TV, we just launched a 64-bit Google TV emulator that includes a 16-kilobyte page size support as well. So together with pointer remote support, this should make it easier for you to validate that your TV app works on TVs of the future. The 64-bit requirement is also coming to watches. So here, too, the new Wear OS 7 emulator will help you ensure that your apps are ready for that. And to build amazing desktop apps, we recently published the desktop emulator. So maybe you're wondering, how do I know I'm on the right track? You should always make sure that your app adheres to the app quality guidelines. See the adaptive app guidelines to see how your app can support multiple form factors, and review the dedicated guides to see how your app can stand out on each form factor. We recently expanded the quality tiers for different form factors as new experiences like the ones we covered here today are being unlocked. For example, on TV, I just published differentiated guidelines to help your app make the best business decisions to stand out on TV. And similarly, the desktop team has recently overhauled the desktop app quality guidelines and the desktop app design gallery. I can highly recommend this particular video on the Android Developer YouTube channel to learn about designing and building desktop-class Android applications.
That's a lot of new features that bring different Android form factors together. And to make it easier to implement them, we've updated our documentation for these various integrations that you've seen so far, both for you to understand and also for the AI agents to interpret, so they can accurately assist you with implementing them, whether you're using Gemini in Android Studio or Android CLI through an LLM of your choice. Finally, we've also updated some of our best samples to include adaptive features, like the adaptive Jetstream sample.
If there's just a few points to take away from our presentation today, it's this. One, build your app according to adaptive app principles to enable it to easily adopt new and emerging form factors with minimal effort. And then build upon that to identify ways in which your app can differentiate for each form factor. And then lastly, to make that easy, make sure you use the plethora of resources and tools we're continuously updating to reflect our best practices. And LLM can help you with that. I hope you're as excited as we are about the future of Android. Thank you.